Hey everyone, I'm excited to be talking about DAX. And in the past I've labeled this an advanced introduction to DAX because what we're going to talk about are a lot more of the concepts that you need to know to get oriented with DAX. And we're not going to spend too much time in the super basics. So my goal is at the end of this presentation, you'll have an idea of what you need to learn next, where to go next, that sort of thing. My bread and butter, what I focus on is Power BI. And Power BI is difficult to teach and to talk about, in part because it's made of a bunch of different components that were originally Excel add-ins, and then we're all kind of mushed together. And one of those that we're going to talk about is DAX, which is the expression language or formula language for the Power Pivot engine, as you might call it, or the DAX engine or the VertiPaq engine. And it's one of the more difficult pieces to learn because it requires taking some things that you learned, throwing them out, starting over. So the important thing to start off with is what DAX isn't. DAX is not Excel, it's not SQL, it's not MDX. And this is important because when I was first learning this about 5 years ago, I think I started with DAX in 2016. But somewhere around 5 years ago, I thought, oh, okay, well, I know SQL and I know Excel formulas, and this looks like Excel formulas, so how hard can this be? And this is actually not correct. It was painful. And the issue, like I said, is that the concepts are harder than the syntax. Many DAX formulas are actually very elegant and concise. And once you know the formula, it's easy to read. The problem is that the DAX engine is a column store engine, which we'll talk about. And what it means in practice is that the fundamental unit of measure is the column, not the row, not the Excel cell. Also, because it's designed for analytical reporting, it's extremely good at two things. DAX is good at two things. And this is so important, this slide shows up 3 times. DAX is good at aggregating and filtering. And so if you're not doing those 2 things, you're using the wrong tool. So DAX, very powerful. You can do a lot of filter manipulation. You can add filters, get rid of filters, make slight changes, all these sorts of things. And we'll talk about that. But if you're using Crystal Reports or SQL Server Reporting Server to make an invoice, you're doing just the tiniest bit of aggregations to maybe get the total, and you're doing the tiniest bit of filtering to filter on a specific invoice. But really, what you're doing is displaying descriptive data. You're not doing analysis, you're not doing KPIs, measures, any of that kind of stuff. And so DAX and Power BI would be terrible for making invoices. So if you're not doing these 2 things, don't use DAX. So let's talk about that learning curve. The learning curve is deceptive. So here we have difficulty on the vertical axis and functionality on the horizontal axis. And the idea is you start at the bottom left, and first you learn about scalar functions and calculated columns. So scalar function, that is a fancy mathematical term for a function that returns a single value. So you think about something like square root, or you're concatenating 2 strings together, or you're taking the min of 2 numbers, or what have you. Scalar functions are kind of what you're used to in Excel. Calculated columns are also like what you're used to in Excel. You're taking a formula, price minus cost, and you're making a new column based on that, and you're storing the information. So if you've worked in SQL, this is like a persisted computed column. And so if you're coming from an Excel background, you're like, I know how to do this. And then bam, the learning curve shoots up and gets a lot more difficult and finally starts to level out. And so what I want to do today in 45, 60 minutes, however long it takes us, is to talk mostly about this center part, where the learning curve gets steep before it starts to level back out. And so what specifically are we going to talk about? So I've got a handful of things that I want to try and cover. Going to be talking about the core concepts, like I said. So we're going to start with calculated columns versus measures. These are the 2 different ways that you can embed business logic, how your business works, into your reporting. And the secret answer is you should always try to use measures where possible. We're going to talk about columnar storage and how the DAX engine is able to compress data to make it lightning fast because it's an in-memory columnar storage database. And so when architected properly, super fast. And a lot of these same concepts are going to apply to if you use Power Pivot and Excel and that sort of thing. Going to talk about aggregations, going to talk about filtering. These are the two things that DAX is good at. And then we're going to talk about filter contexts and iterators, which are slightly more advanced concepts. So there are two types of business logic, or two ways to implement business logic when you're working with DAX. There's calculated columns and there's measures. And so what do I mean by business logic? Well, what I've learned in my, I think it's 8, maybe 9 years. I'm losing track of how long I've been working in this field. It used to be that my last job started right when I started dating my spouse. And so I could just keep track of both. But now I don't know. But we'll say 8. In my 8 years of working in this field, I've learned that you can have two businesses in the same industry. My last job, it was fire protection services that work completely differently. And you might ask, well, how do we determine gross sales? And they'll say, well, it's sales quantity times unit price minus the discount. And then if it's this one customer, we charge them an extra 10% because they give us terms of net 120, so they take so long that we have to account for blah, 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 blah. And then you just fall asleep. The part that's important is that every business is unique. And so you need some way to encapsulate that so that your users can just pull gross sales and not have to worry about it. So calculated columns. A calculated column represents a single value for every single row. And it's pre-calculated. It's computed at time of creation and refresh. And those results are materialized and stored within the table. What I'm basically trying to say is that this takes up space. It is real. It is not a promise to calculate something on demand. It is pre-calculated and it takes up either storage on disk or space in RAM. And so you want to take that into consideration whenever you're adding calculated columns. And it's attached to a specific table. And so it's part of the table. Once it's been calculated, it is functionally identical to other columns in the table from a user experience perspective. And normally, expressions in a calculated column can only see the row that it exists in. It's kind of like having these horse blinders where you are able to refer to another column and like price minus cost. And it only looks at the specific cell within the row because of something called a row context. So we'll talk a little bit more about a row context later. The one thing that you can do with calculated columns that you can't do with measures is that you can put a calculated column, like say you make age bands, for doing marketing or something like that. I'm soon leaving the coveted 18 to 35 male marketing segment. You can put that into a filter, or you can, put that into the results area. And you can't filter directly on a measure. There's ways around that. You could do like a top N sort of thing. But in general, calculated columns are really good whenever you want something that you can add as a filter or something like that. So let's look at an example. So here I have unit margin. In the picture, it's called gross margin, but really, more accurately, it's unit margin. The idea is I have these different products. And what I'm doing is I'm just saying I want to take price minus cost. And this works the way that you would expect it to in Excel. It just takes price minus cost. And because we're doing a calculated column, because we have a row context and it's limiting us to that specific row, even though we're referring to the name of a column, it's smart enough to give us the name or the value in that specific cell. What you'll find working with DAX is that it's not always the case. This naming is contextual. And so it can be a source of a lot of confusion because when you're working with SQL or Excel, you're used to this just working. But when we're dealing with DAX, we have to be a little bit more thoughtful. So that's a calculate column. A measure represents a single value per data model for a given point in time, for a given context. And so this is computed at runtime. This is computed in response to the user clicking on something or pulling up a page or what have you. And it's dynamic based on the filters that are applied both by the user and by the code or the report layout or what have you. And so this is called a filter context. And so what you'll find is there's two types of contexts in DAX, and these determine how your expression evaluates into the final result. And these are called evaluation contexts. And a measure is not attached to any specific table. It is associated with one from a UI perspective. But one of the things that you can do is you can make an empty table with no rows and no data and put a bunch of measures on it, and those measures work fine because they're looking at the data all at once. It's taking a bird's eye view of the data. And so if we look in Excel and we're looking at Power Pivot, we can see, okay, we've got total quantity, which is just taking the sum of sales quantity, but it's down below, it's at the bottom. It's kind of aloof. It's not attached to the table. And here it's showing us the number 17, but that's not being pre-calculated and stored anywhere. That's being calculated on demand, on the fly. Finally, even if you never create a measure, you might be creating an implicit measure. So if I take quantity and I just drag it into the values section of a pivot table, for example, or into a bar of a bar chart, it's going to create this implicit measure that I can look at that's just the same kind of formula, but I don't see it normally. It just works. And so even when you don't think you're using measures, you're probably still using measures. So those are two ways that we can embed our business logic into the report. And like I said, DAX is good at two things. It's good at aggregating and it's good at filtering. So what's an aggregation? An aggregation is pretty simple. We're just taking a group of values and combining it into one value. And so if you've ever used SQL, if you've ever used Excel, you've done this before. You know how this works. We can take something like quantity, we squish it together, and using sum of quantity, we get a single value. Now, this, like I said, is kind of the bread and butter of analytical reporting. Very often, we're looking at large periods of time, we're doing comparisons, and we're trying to get our measures or KPIs to say, how is the business doing? What was total sales for a given quarter? And what's interesting is that the DAX engine stores data as columns. So it's super efficient for simple aggregations. So if you're just doing basically the equivalent of scans and basic arithmetic, then the DAX engine will use a subcomponent called the storage engine, as opposed to what's the other one was called the formula engine. I'm not going to get into those in depth today, although I'm happy to talk about it after. But basically, if your aggregation can be reduced to a simple scan plus filter kind of thing, then it's super fast and just really efficient. And so many aggregate functions take in columns as parameters. So when we don't have that row context, when we refer to a column name, what you're actually passing in is the entire column, which is stored separate from other columns. And so again, DAX is optimized for these single column operations. Columns are the fundamental unit of measure when it comes to DAX. So what do I mean? Well, let's imagine that I'm selling products in the tri-state area here. So sorry, Virginia, you didn't make the cut for my imaginary store. I'm selling t-shirts. Here's a blue t-shirt. And I want to do a report on sales by color, right? I just want to see what's the most popular color, because everybody has a favorite color and maybe there's some genetic component to whether you like green versus blue, who knows, right? Well, if I was doing this in SQL Server, there would be an issue. And so the issue is that SQL Server is a Rowstore database, which means, imagine I have 50 columns, okay? Even though I only want data from color and quantity, I have to read the whole row, and I have to read row by row by row, right? And in SQL Server, data is stored on these 8 kilobyte pages. And so even if I don't want the other data, Unless I have an index to support this, if I'm pulling from the main table, then I'm reading that entire 8 kilobyte page and I'm pulling in all this information I don't need. Whereas if we were to store things as separate tables, then I could read color and I could read quantity and I can compute my values. The other thing with the columnar database piece is compression and encoding. So the key part here is that the DAX engine will encode, basically store in an efficient manner, the data in 3 different ways. There's value encoding, which we don't need to get into a ton, but basically, I'm a diabetic, and so I have to get blood work done on a regular basis, and I'll get invoiced by Heritage Valley Healthcare. And what's funny is that I'll have an account number, and the account number is easily like 10 or 16 digits, right? And I can promise you, this little podunk healthcare system in Beaver County does not have 10 million customers, right? What's going on is some IT person decided, oh, we'll put the department number first so we know where to route the bill to, which makes sense, but you end up with these big numbers. And so if my account number was 16,500,233, value encoding says, well, why don't we store 16,500,000 over here? And then just store the delta, which would be 233. And so if you have a narrow range of integer values, it'll store the base and then store the delta. You also have dictionary encoding. So dictionary encoding, here in Pennsylvania, we have the world's most famous groundhog, whose name is Punxsutawney Phil. And Punxsutawney Phil is a really long name. And so you can imagine if I had a bunch of groundhog facts in some database, maybe I don't want to write out Punxsutawney Phil, Punxsutawney Phil, Punxsutawney Phil every single time. And so what I could do is I could say, well, I'm going to write the number 1. And then later, if I need that information, I'll look it up. And it turns out number 1 maps to Punxsutawney Phil. The DAX engine will do the same thing. And so for repeated values or long values that are repeated, this can be really efficient, right? Where it's inefficient is whenever you have unique values like not graphical user interface, globally unique IDs, keys, date times, all these sorts of things. So you have to be careful about that. And then there's run length encoding. So this depends on sorting. We can imagine, again, we have our column of colors of t-shirts sold. And if we sort by color, you'll notice that we have blue and then green, green, then red, 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 red. Well, there's a more efficient way to store this. I can store the color and then the number. So red, 4. And so this is ideal for analytical data because generally speaking, we have a tendency to denormalize it, to flatten it out. And so even if you have millions and millions of rows, these repeated values can be stored extremely efficiently, assuming you're only using the bare minimum number of columns necessary in your table. Every column that you add makes this run length encoding perform worse. Because you can imagine, first we sort by color, that's super efficient. Then maybe we sort by quantity, and that's slightly less efficient because it's fragmented by color. And then we sort by username, and then that's really inefficient, right? So the key part I want you to get is that the DAX engine is super optimized for columnar analytics. And so the other thing that DAX is good at is filtering. So we're doing these aggregations. We're looking at lots of data, usually over long periods of time, to get single value results often of how is the business doing. But the other thing that we care about a lot in analytics is comparisons. Either we want to compare 2 different regions or periods of time, or we want to dive down into the data and look at a subset. So we're either looking at subsets or making comparisons between subsets. And so for that, we need to do filtering. So there's 2 types of filtering when it comes to the DAX engine. And so there's different names for this. I've heard it described as user filtering versus query filtering, but the way that I like to describe it is implicit versus explicit. So implicit is filtering done by the layout and design of the report or by the user itself. So we've got slicers, But we also have something like cell location or bars in a bar chart, right? Where basically, if you have a bar chart on category, each bar is applying a filter to whatever measure that you've created. And what's interesting is that we can override that. So here we've got, at the bottom, we've got a pivot table and we're filtering by color. We've got green and red, and I could override that. I could write code, I could use calculate, which allows me to override a filter context. And I could say that color equals green. Even when I say it's red, it's actually green. And so just something worth mentioning, which is a point of confusion, the default behavior with calculate is if you are overriding a single column filter, we're saying color is green. What it actually does is it functionally undoes any other filters and then applies green. So it's an override, not an intersect, if that makes sense. And you may be saying, well, why would I ever do this? Why would I want to pretend that red is green? And where you would actually do something like this is whenever you want to do a slice of pie analysis, right? Maybe I want to know, okay, how much of this color was out of the total pie of sales? Or maybe I want to know, how much did we sell of this color relative to the year before, right? So I want to take the current year, I want to get rid of it, and I want to put it in the year before. Extremely common when you're working with this kind of stuff. Another thing is we have this idea of filter context, which I've talked about. And it's a combination of the user filters, those implicit filters, and later, anything that we use to override it. So we've got basic filters that are associated with specific columns, but you can also apply filters to entire tables if you're doing some kind of multi-column kind of logic. And so again, calculate is a function that allows you to overwrite the filter context. It allows you to take everything the user's done, the layout of the report is done, and say, nah, I want something different. I actually want last year. I want year to date instead of today, right? Just did work for a customer where instead of today's date, they wanted the previous 7 days as a rolling average, and we use calculate to do that. One of the other things that you can do that you can't do in SQL is you can remove filtering. So the all function removes filters. It gets rid of filters. And so you can use this on a whole table or specific columns. So again, if I want to do that slice of pie analysis now, I could have a measure called all colors that says, okay, you said it was green. I want to look at everything. And then later what I could add in is total quantity divided by all colors. And now I've got my percentage, right? And you'll see that I'm doing all of sales color. So I'm just undoing a filter on a single column. If I'm dissecting the information by type of food, that doesn't have anything to do with that column, so it's not affected by the all here, right? What if we want to apply complex filtering? So up to this point, we've been talking about single column filtering, single column kind of stuff. But if I wanted to say, okay, I want to see all the sales for low margin products. Where was my price minus cost less than $1? Where did I make less than $1? I'll get this long arrow that I have to squish. It doesn't even fit, right? And what I have to do is I have to use something called an iterator. Because remember that we're storing our data as separate columns. It's like you and your roommate. Like you live in the same apartment, but I mean, you're not, sharing the same exact space, right? You're not bound together. And so an iterator will kind of take multiple columns and zip them back up together to make them a cohesive whole. And so filter is an example of an iterator. It takes in a table and an expression and returns a filtered table. So if we wanted to do this kind of analysis, what we would do is we'd use filter. Filter takes the sales table and we say, hey, I need you to get price and I need you to get costs, and I know they're kind of estranged and living separately, but I need you to bring them back together so I can evaluate for each row, is this less than or equal to 1? And if it's true, it returns the row, and if it isn't, it discards it. And so now we can see, okay, here's our low margin products. And so filter is one example of an iterator. An iterator processes tables row by agonizing row, which isn't efficient when you're dealing with columnar storage. It can be expensive, but in my experience, it's usually not too bad if you're doing basic arithmetic, like I said, right? If you're just going through and doing some sort of like plus minus like we did, something where it can do a table scan, it's not too bad. Whenever you start nesting iterators or you have to go out to another table, that's when it starts to get particularly painful. But for something like we just did, not a huge issue. But rows are filtered one at a time by using a row context. And so oftentimes you'll have both a filter context and a row context that's being applied. And it's outside of the scope of this talk, but there's some complex things you can do. There's something called a context transition where you can turn a row context into a filter context. But anytime that you want to refer to multiple fields in the same row, you need a row context. It's just required. For calculated columns, it's done implicitly. In other cases, you have to do it by hand. And so if I wanted to take the total price minus cost, the total margin, and I try to just do something like sum of price minus cost, I'll get an error. And so how we get around that is by using an iterator. So if I want to find out the average margin, I could take average of gross margin or unit margin if I had that column already. But if I didn't, I could use a function called AverageX. For whatever reason, they've decided that they wanted everything to be extreme. Somehow X stands for iterator. And so here I have to give it a table, and I'm subtracting cost from price. And these produce identical results. These are functionally identical. The difference is that average, oh, my dog Tyson's getting angry. The difference is the first one takes up more space because we have to pre-calculate these values, but is in most cases going to be faster. And the second one isn't necessarily as fast because it's calculating things on the fly and it's iterating through the table. But for a small table for some regular stuff, it's going to be functionally the same, right? I wouldn't worry about performance until you start seeing a performance issue. But in most cases, your iterator functions require a table to iterate through. Okay, so a couple other things that I want to talk about. My dog Tyson is very grumpy. I think my dad might be here, and he does not like my dad. All right. So give me 1 minute.
I was too late to push the button. You beat me, Eugene. Right? Hey, there we go.
Yeah. Everyone say hi to my co-presenter Tyson. He is a very ornery black long-haired Chihuahua. Okay, so now that he is not distracting me so much with his little borks, there's a couple other features I want to talk about, and then I have some book suggestions, and then we're going to have plenty of time for any questions that anyone has. So one of the other features in DAX is time intelligence. Now, time intelligence sounds fancy. You're like, oh, they're using artificial intelligence to help me with my date-based reporting, and no, it's not that. Oh, he's grumpy. Time intelligence requires a date table. And all it does is it manipulates date filters in an intelligent way, but it's really just syntactic sugar. These are convenience functions. So for example, if I wanted to calculate sales for a year to date, what I could do is use the dates year to date function on my calendar table. Now, here's the issue. One, it has to be a properly formatted date table, which means that it has to be contiguous, no gaps, no blanks, nothing like that. Also, what it means is that we're doing a filter manipulation, right? So we could do this all by hand, and basically we're saying, all right, let's undo whatever filter was applied on calendar date and redo it as from the beginning of the year to currently. So time intelligence is really, really useful, but there's nothing magic about it. It's just like 20 or 30 different functions that Microsoft made to make your life easier. The other piece of functionality I want to mention is quick measures. So as far as I'm aware, this isn't available in Excel, but in Power BI, they have quick measures, which are a quick template-based system for making DAX formulas. And it generates real DAX. And what you do is you go to quick measures in the toolbar, and you can pick minimum per category. And you say, okay, I want to take my forecast as my value, and I want to use my category column as my category. And what's cool is you can see over on the left, it creates a real formula. And then you can go and look up each of these and see what they do and understand what they do. All right, so that's the main content. A couple quick book recommendations, and then happy to answer questions anyone has. So first, I recommend everyone who has the most modest interest in learning DAX to buy this book. It's Analyzing Data with Microsoft Power BI and Power Pivot for Excel, which is a mouthful. But what I really like about the book is it's short and it teaches data modeling. And I personally found this helpful because a lot of data modeling I had to learn on the fly as I went. Tyson, why you got to be like this? All right. I learned data modeling on the fly. And so it uses DAX as the language, but it really just covers a lot of the fundamentals. So it's a really good book. I think it's only like 200 pages, 100% recommend it. Another book that I used to learn was Power Pivot and Power BI. And this is probably one of the only technical books I can imagine reading on the beach, for example. And it's a really easy read. It's a great general introduction. The problem is it's getting a bit old. This was released in 2016 and a lot's moved on since then. But I think that, if you're looking for something that's kind of a gentle introduction, I really recommend it. Finally, if you want something a little bit heavier, then you should check out the Definitive Guide to DAX. So this is made by the Marco Russo and Alberto Ferrari. They wrote that first book I recommended. And if there was exam prep on DAX, this would be it, right? It's very thorough. It's like 600 pages. So only get it if you know you need to become an expert in this area. But it's a little dry, but it's extremely well written. So very good, comprehensive, and it's in its second edition. All right. So does anyone have any questions? Let's see.
So Kevin's asking about a new version of the book. You mentioned I don't know. I think he was talking about the 2016 one.
So I went and checked. So let's let me share again, because I'll just. So this one I need to check. I don't know if there's a new one for that one. The Power Pivot and Power BI, the 2016 one, I checked this morning and I didn't see a new version. And then this one, this used to be like the purple book, and this is the second edition, and this is new. So if there's a specific one that he's thinking of, awesome. But yeah. So I know the Definitive Guide, that one. Oh, I was not sharing my screen, was I? I'm bad at this. Here, let's try this again. One moment.
Too many buttons.
Yeah, I know. All right. Here, let's try this again. Okay. So this one has a new version. This one's on second edition, and it's very, very good. I checked the Power Pivot and Power BI literally this morning to see if they'd come out with a new version, and I haven't seen it, right? So maybe there is a third edition. It's hiding somewhere, but I haven't seen it. It's a great book, but I'm not sure if we're going to see one come out, because I think Rob and Avi have kind of gone their separate ways. And then this one I feel like is pretty new. I mean, it's a couple years old, but let's just see real quick. Let's go on Amazon and see.
Yeah, it's
Marco
funny
Russo.
With that Azure documentation, or with online documentation now. I mean, the books, like, yeah, you feel like it's pretty new, but it's hard to keep up with the change of pace, or change of
yeah. So this,
change, that's what I'm looking for.
I know. The Definitive Guide came out in 2019, which feels new because the past 2 years were kind of a blur.
Right.
Let's see. Analyzing. Oh, come on. Let's see when this one came out. I'm not. I don't know. Let's try paperback. I don't think it tells us for Kindle. Oh, I must. Oh, I guess I bought it back in 2017, so it can't be that new.
Oh, there we go.
It's still. I mean, a lot of it's about fundamentals and stuff, so it's still very good.
Sure.
But usually it'll say if there's another version. So I don't think they're
right.
Actually, you know what? They have a great website. Let's do, instead of trying to depend on Amazon, which has gotten shadier as time goes on, unfortunately. Like they like pushing that. Let's see what books. What do we got? Okay, yeah. So looks like it's the latest stuff. And like I said, when I looked for Power BI and Power Pivot, you know, let's see if Rob's done anything new. Yeah, see, I think that's the latest version, which is a shame because it's a really good book. There's other books as well,
Sure.
but these were all ones that I found particularly helpful. Oh, he said might be Radicat. Yeah, so let's see what Reza did put out something new. Power BI simplified DAX. I have not given this a look, but for $10, I probably should. but they're both. I mean, they're both great. They're.
Sure.
I mean, Reza and Leela are both wicked smart, so I can recommend anything that they make for sure. Cool. So, do we have any other questions? And if not about DAX, I'm happy to talk about Power BI in general, or even consulting, or any of that kind of stuff. Let's see.
Sure. One of the things I noticed, right, is that you mentioned so sometimes the obstacles of getting up and started. But one of the nice, I don't know if nice is the right word, but one of the I have noticed, however, that once it is written, it is fairly easy to explain to others.
Yes.
And it's fairly easy adaptable, right? So I mean, they may not, as opposed to like learning a foreign language, you may not be able to speak it, but you can understand it a little faster, right? Than you can speak it.
Well, one of the things that's nice is they've got support for comments. I think a couple years ago they added support for variables, so you can make it a little bit cleaner. I think where it becomes difficult is, I think, 2 or 3 things. So one is I hate their formula naming, right? So literally, like you think about like the calculate function.
Problem with naming.
I know.
I mean, like
so like that calculate function. They finally added a new function called remove filters, or not. Sorry, not calculate, the all function. They added something called remove filters, which is a little bit more intuitive for what it does. Or you think about calculate. Back when I was learning this, I thought anytime I wanted to do an aggregation, I had to wrap it in a calculate, right?
Yeah.
And that's not the case. It's when you want to manipulate that filter context. And so one of the big challenges is the naming. Another big challenge is debugging, right? Getting it to work the way that you want, because it's got these layers, and it's hard to tell, like as you're going through the layers of Inception, like the movie Inception, what the data looks like at that specific point. And so one of the biggest skills that you can have is breaking up your formula into smaller chunks and looking at those pieces, right? And we've had that with customers, like when we did the stuff with Flight Service Pro, we broke that up so they could validate themselves, like here's what it's doing, right? They can see each of those individual pieces. So yeah, the formulas aren't bad, and usually once you know the name of something, you can look it up, right?
Sure.
But you're never gonna guess the name values for the values function, right? You're never gonna be like, oh, I need thing that gives me the unique list of what's in this column. I'll use values. So SQL, you can manage to like learn your way through blogs. It's getting a bit better now, but still, Like there's a lot of stuff like just buy a book, or I've got a course on Pluralsight or something,
Hey,
you know, that's going to run you through like all those stumbling blocks is my recommendation. So, but yeah, once it's written, it's usually pretty readable.
there you go. Okay. Very good. So let's see.
See.
Kevin asks, right, can DAX be submitted to SQL Server or only when in tabular SAS mode? I think basically, well, so I guess the question really is where can I use DAX?
Yeah, so I that's a good question. So you definitely can't.
Oh, I
Well,
would have thought that would have been a much easier question, but
no. So there's two things, right? So first off, let me see if let's share. We'll do a live demo. We're gonna do it live, folks. Right? So, boop, boop, boo. So there's two pieces to this, right? So
I
one,
would have just said it's it's only available in Power BI. Well, I guess of course it's
no,
in Excel, the
well,
Excel piece, right? I guess
okay.
that's the
So
tricky piece. Yeah,
it's a multi-part question, right?
there we go.
So first, let's see if I have SQL Server running. Da-da-da. Okay, so I do not. Let's start that up. And then kids, do not do this at home. I'm going to run Profiler, which is old enough to drink. Aaron Stellato will beat me up if she finds out. So I hope this isn't being recorded. She's firm.
When they give us a little better tooling to be able to right click and be like,
I
hey, I just
know.
want to grab everything from this
If you've
database.
got it memorized, you can get the extended events going in like a few clicks. But who has time for that?
That's right. You know.
So
We've got all this DAX stuff up here. We got to remember, right? Like
I know. Okay. So here's what I want to communicate. So let's open up Power BI. Yeah, my dad's raking leaves because that's his love language is like acts of service. So he's raking leaves, which I appreciate, but Tyson can't stand him. So that's what he's getting
oh
all
gosh.
borky about. Yeah. All right, come on, Power BI. So the can it be used against SQL Server is kind of a trick question because SQL Server does not, like the regular relational database, does not natively support DAX, right? But what you can do is you can use direct query. And so what direct query does, let's see, localhost, is that it translates DAX code live into SQL queries instead of actually evaluating them. So let's see if that'll work. So Adventure works. Sales. So if I just load that, did I tell it direct query? We'll find out. I feel like I did. I may not have. I think. Let me try. Let's try this again. Get data, SQL Server. Oh no, I have direct query. Okay, sorry about that. Oh, localhost. I promise when we do consulting for folks, we don't charge them for like me mistyping every single thing. Localhost. Okay. So sales. Okay. So let's go ahead and pull it in twice. That's funny. Oh, I renamed it, but so let's clear all that out. Okay, so here's what I wanted to show, right? So we can make a measure. We'll say a new measure. Just call it total sales, right? So total sales sum line total. Okay. So now, if we clear this out, I can make a table. It's going to be a little hard to see, but I can go ahead and add total sales, and I can add, we'll say order. There's my product ID. And what it's doing is it is in fact writing SQL on the fly, right? It's not the prettiest SQL, but we can see that it's writing SQL on the fly, right? So technically, you can talk to the raw SQL engine with DAX. Now, as for SQL Server analysis services, let's see, I forget. Here we go. So I think that it can talk to both. I think it's able to talk to multidimensional and SSAS, but honestly, I'd have to double check, right? Because I know like Excel, when Excel's talking to it, it's writing MDX queries and those are getting translated and that sort of thing, right? If you're using like the analyze in Excel. So I don't remember off the top of my head, but I'd be willing to bet money that yes, you can actually run DAX against multidimensional, but it's not as efficient, right? Because it's having to do that translation. So hopefully that answers the questions there.
Yeah, thanks for being here, Eugene. Right, sharing what you know. We do appreciate it. And yeah.
Cool.